So I converted the mixed numbers into fractions.
Okay.
And then I found a common denominator. And then 40 minus 21 is 19. And then I converted it back into a mixed number.
Is that a sensible answer? Did you check it some way?
Kinda.
How?
I took this and I kept it like this and then went through the problem again.
You just went, kind of
Yeah.
checked your work, double checked your work. That's one way to check, is look at your work again. Or
I'm not sure what the different way I did it.
a different way of getting the answer. As soon as I get somebody to tell me how they checked it, what are our ways of checking this to see if we're right?
Calculator.
Calculator. You could type in 3, can everybody type in 3 1/3 on their calculator? Minus 1 3/4. It'll probably give you a decimal answer. And so you're gonna have to then do something, or
You can just add 1 3/4 to your answer, and if that's 3 1/3, then you know it was right.
did everybody hear that?
It's a fact check.
We can take the result, 1 7/12, add 1 3/4, and we better get 3 1/3, because, as someone said, this is the same fact family, right? Here's the addition problem, here's the subtraction problem. So we could add these, right? Which means we'd have to get a common denominator and so on. Okay, Morgan, you said you did this a different way. Any other ways to check it besides adding the difference and the subtrahend to see if you get the minuend, or using a calculator? Anybody?
Just check if your neighbor are friends.
Yeah. If it's not an exam, you could just turn to your neighbor and say, did you get the same thing I did? There we go. Anybody else? Come over here, would you please?
Sure. So,
Why would I ask Morgan to come over here and do the problem so we can compare side by side?
right.
That's an important thing. If you're doing two different,
Morgan, you need mine. I got you.
she wants to know which one was which problem.
Okay, so first, instead of converting them to mixed numbers, I just found a common denominator between the 3 and 4, and I realized, oh, well, 3 times 4 is 12. So I put them both with denominators of 12. And then I realized something, because we've been doing all those clock problems, and I thought this was kind of like a clock problem when you're taking that 4, when you're taking 9 from the 4, because then it's going to be negative, and I was like, okay. So if I treated it like a clock problem, then obviously it was like if you took, you could take the 9 from the 4 by one of the methods we learned with the clock. So I thought, oh, okay, well, 9 minus 12 is 3, so I can add that 3. It's kind of weird. That's the inverse method. My brain is like, anyway. But do you see what I'm saying? Like,
Keep going.
so I said, all right, well, the leftover, like if I took, like if we treated, it's so hard to explain. Like a clock problem, like if this was 12, this is 9, just for the fraction part of the question, then I realized that I can just add, I can take 4 and add 3, and that would give me 7. So I realized with the fraction part, I'm going to have that 7/12 left over. And then I thought, okay, we're going to have 3 minus 1, and then plus we have to take away another 1 because we went backwards. So then I realized it would be 1, 7/12.
Wow.
But that was really confusing. I just thought it was cool how you could apply it.
She's got her mind in the clocks and she can't forget it.
Oh, okay.
I did it kind of like the first one.
Kind of like this one.
Yeah.
So you turned it to improper fractions first?
No, except instead of, it was a little different. I just found the common denominator between the fractions, and then did an exchange. So the first one was 2 and 16/12, minus 1 and 9/12, and so then I could just subtract the fractions and subtract the whole numbers.
I think where you're going is this. I go to subtract 3 minus 1, the whole number part, remember the like terms? I can do that, I can get 2, right? But when I go 4/12, take away 9/12, I don't have enough. So what I think Samantha did was she made an exchange, came over and took a whole, which left 2 wholes, but that one whole is how much? 12/12. Well, I already have 4/12, and now I've got 16 because I got 12 more, so I've got 16/12. And so we've made an exchange. Now I can do the like terms. 2 minus 1 is 1. 16/12 minus 9/12 is 7/12. Is that?
Yeah.
So did we have to do the improper fraction thing? How many of you did the improper fraction thing? Because that's probably what your teacher taught you to do. Watch this, slightly different but very closely related to what Samantha's done. Instead of exchanging, I'm going to go 3 minus 1 is 2. And then 4 minus 9 is negative 5/12. Well, if I have 2 wholes and a minus 5/12 and put them together, now you're thinking chips, right? And these negative 9 or 5/12 will cancel with 5 positive 12s, leaving what left? 1 and 7/12. There's a different way of thinking about it that's... Does everybody follow that? You want your kids thinking about it in all different kinds of ways. They all should give us the same answer, but they don't necessarily have to take the same solution, the same direction. There may be other ways. Invite your students to share. Sometimes some of the ways are a bit esoteric. We won't mention any names. That's okay. It's all right to have a student share a method that you as the teacher go, I see what he's doing or what she's doing. Maybe the rest of the class doesn't, but maybe it's not important that everybody in the class see all of the ways. Why might it be important for Morgan to come up and be able to do that? Even if other people don't follow it.
Well, that's the way that she's comfortable with, so she's going to be able to use that, and she gets it, and she's always
Okay.
going to get it, and it's going to stick with her longer.
What else?
I think it validates her and lets her know that her way, because you
I
said,
can-
yes, that's the right answer, and that's.
I can think well
Yes.
in math. I may not think like everybody else, but I can think well. And that's what it's all about. It's not, if you haven't got that so far this semester from me, it's not about memorizing procedures and teaching kids those procedures. Math is about sense making. And you've got to help your kids and allow your kids and encourage your kids to make sense of their math. It might be coming from a totally different approach. Okay? Why? Why do we need to help kids make sense of math, not just learn procedures?